Hello all, and thank you for listening to Mr. Laxton's video on these Algebra 2 Section 1.2 notes. Alright, today we're kind of getting down into the thick of things in Algebra 2. Section 1.1 we looked at a lot of the definitions. Now Section 1.2 we kind of get into more of the actual evaluating and the actual working with some numbers here. Alright, so the first one, as I look through here, is Section 1.2 is algebraic expressions and models. So my essential question today is, how do I use the order of operations? Alright, and we're going to call this PEMDAS. Maybe you've heard of that, maybe not. So we're going to learn about that today. How do I use PEMDAS to evaluate an expression? All right, so a numerical expression is just that. It's numbers, operations, grouping symbols. It's anything that's got adding, subtracting, multiplying, dividing. An expression does not have an equal sign though. So an expression is just numbers and operations and grouping symbols. All right, so a power for my first one is a numerical expression with a base and an exponent. All right, so hopefully some of these words are coming back. They're making some sense. Power is a base that is raised to an exponent. So here's an example: is 2 to the 5th power. So 2 right here is my base, and the 5 is my exponent. So what this really means is 2 to the 5th power means that I'm going to take 2 and I'm going to multiply it by itself 5 times. So here, if I look 2 times 2 times 2 times 2 times 2, you could do it in your head. You go 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. All right? So 2 to the 5th power is 32. All right, the base is the number that's being multiplied by itself. So as I said there, hey, 2 is the base. All right, the exponent is the number of times we multiply the base times itself. So I multiplied 2 by itself 5 times. So that was my exponent there. Be careful here that the parentheses in these do matter. All right, and you got to be really careful when you're plugging these things in your calculator. Is this one is pretty straightforward. 3 to the 4th power, 3 times 3 times 3 times 3 is 81. Great, put it in your calculator, that's fine. But now as I look at this, negative 3 in parentheses to the 4th power is negative 3 times negative 3 times negative 3 times negative 3. Notice here that this is an even number of negatives, so that's going to equal a positive number. So here I come up with positive 81. All right, but now if I look at negative 3 to the 4th power, no parentheses, do you see the difference? That's going to be 3 to the 4th power first, so it's going to be 3 times 3 times 3 times 3 times a negative 1, which is going to give us that negative 81. So got to know the difference. Does it have parentheses? Is it in parentheses? Is it not? That makes a difference. All right, the next one, order of operations. This is how I learned it. This is how I like to teach it. I think it's nice. I think it's easy as PEMDAS. All right, and I hope you guys have heard this before. If not, we'll talk about it. All right, so this is the order of operations, what we need to do first when we're evaluating these expressions. Okay, the first thing that we always do is parentheses. All right, so this is parentheses. All right, always do the parentheses first, whatever is inside those parentheses. All right, the next one, we're going to work this guy from top to bottom. So after we get done with all the parentheses, then we're going to, hey, say, what are all my exponents? I got to do all those next. All right, so we just kind of talked about those. Exponents is a lot of times you'll see something in parentheses to the 2nd power or 3rd power. So you got to do what's inside the parentheses first and then raise it to that power. All right. Next, the M and the D mean multiplication and division. All right, and notice here that these guys are kind of on the same line. They're not different because we have to work these guys from left to right. So maybe you want to write yourself a little note in here. We got to work those from left to right. Right does not have an E in it. It has R-I-G-H-T. All right, perfect. So we work those guys from left to right. So hey, if we have a division that comes first from left to right, we do the division first. If we have multiplication, then we do that one. Those are kind of on the same line. And the next ones that are on the same line is add and subtract. All right, so as well, we work those guys also from left to right. All right, variables. We've talked about these, and you guys have seen these a lot, I'm sure, in Algebra 1. A variable is just a letter that's used to represent one or more numbers. All right, so it's just a letter that's used to represent something. All right, so a lot of times we use X, we might use Y. We're going to use Y a lot in Algebra 2, and actually bring in some Z's at some place. All right, so the value of the variable is the next one, is any number used to replace a variable. So hey, this one says let x equals 4. So that is the value of that actual variable. All right, algebraic expression is an expression involving variables. Doesn't matter, it can be 4 variables, can be 5 variables, can be 1 variable. It's an algebraic expression. All right, the value of expression is the answer when you actually plug that in. So if I look at the value of an expression, if I say, hey, if x actually equals 4, what is the value of 2x plus 3? So now I just plug these guys in. So I have 2 times 4 plus 3. So now I look here, I look at my PEMDAS, I have to do whatever inside my parentheses. I can't do anything with just the 4, so there's no exponents. I move to multiplication, so this is 8 plus 3, which is 11. All right. Good, good, great. Terms are the parts of an expression that are added together. So these guys are separated by an plus sign. Separated by plus sign. All right. So terms of an expression. In this guy, 2x and 3 are both terms. All right. So there's 2 terms in that here. X and -7, if I make that into plus and minus, are both the terms. All right. So the constant terms are the terms that do not have any x's. So this one is -2. All right. So those are the terms that with no x's. Like terms, you guys have kind of heard me say this. You're gonna hear me say this a lot more in the coming future. Is you got to combine like terms. So any like terms that are being added and subtracted together, you can combine them. All right. So here, if I look at this, 2x cubed and 3x cubed are like terms. 2x and 6 are not. So they have to have the same x, or they have to have the same variable raised to the same power. All right, so if I look at here, 2x to the first is not the same as 6 because it does not have an x to the first. So if I look at here, if I have 2x and -6x, I'd like to make that plus a negative. So now I have 2 terms. They are like terms because they both have an x to the first power. So now I have 2x's and -6x's. They combine to make -4x's. All right. Perfect. Again, section 1.2, doing some of that order of operations there and see what we can get. Good luck. Come find me if you have any questions. Again, please subscribe and you'll get all this stuff to my channel. Thanks. Have a good rest of your night or day.